Om Shri Sharda Gurubhyo Namaha. First, I would like to welcome final year students of Sri JCBMC College 2020-21 batch. So, in 5th semester chemistry, there are two papers, paper 5 and paper 6. In today's class, I am going to take paper 6 chemistry. In that, inorganic chemistry. So, in inorganic chemistry, the first chapter of inorganic chemistry is coordination chemistry. So, in order to understand what is a coordination compound, first of all, we have to consider molecular addition compounds. A molecular addition compound is a compound which is formed by mixing equimolar proportion of two simple salts and the solution is subjected to evaporation and the resulting solid form is a molecular addition compound. And in molecular addition compounds, there are two types. The two types of molecular addition compounds are, one is double salts and another one is complex salts. So, double salts and complex salts. So, example for double salts are, very common example, bore salt and potash ions. FeSO4, Na5SO4, 6H2O. Or potash alum, K2SO4, A2SO4 times 21H2O. So, then for a complex salt, we can give many examples: potassium ferrocyanate, potassium ferricyanate, ammonium sulfate. Next question is, what is the basic difference between double salt and a coordination compound or a complex salt? Both are molecular addition compound, but they have many differences. The difference is that, suppose if you consider a double salt, in double salt, the simple salts retain their original identity even after the formation of the double salts. In case of more salt, which is formed by the two simple salts, ferrous sulfate and ammonium sulfate, even after the formation of this more salt, they retain their original identity. But here, in case of a complex compound, after the formation of a complex compound, the simple salts lose their original identity. That is the first difference. Second difference is that these double salts are stable only in the solid state. When their solutions are prepared, they give their respective ions. In case of more salt, suppose if you prepare more salt solution, in the solution it behaves as mixture of ferrous ion, ammonium ion and sulfate ion. So here ferrous ion is formed by the ionization of ferrous sulfate, ammonium ion is formed by the ionization of ammonium sulfate, and sulfate ion is obtained from both ferrous sulfate and ammonium sulfate. So in the solution of more salt, it acts as a mixture of ferrous ion, ammonium ion and sulfate ion. Or in other words, we can say that double salts lose their identity in the solution. Whereas in case of a complex compound or a complex salt, when their solutions are prepared, in the solution also they retain their identity. Say for example, if potassium ferrocyanate is dissolved or its solution is prepared, it ionizes to give potassium ion and ferrocyanide ion, potassium ion and ferrocyanide ion. That means the complex ion ferrocyanide ion is present even in the solution also. So that's why complex salts retain their identity even in the solution. So that is these two are the basic differences between a double salt and a complex compound. Both double salts and complex compounds are molecular addition compounds, but in case of double salts, the simple salts involved in the formation of double salts retain their identity even after the formation of the double salt, and double salts are stable only in the solid state. When their solutions are prepared, they act as mixture of their respective ions. But in case of a coordination compound or a complex compound or a complex salt, the simple salts involved in the formation of those complex salts lose their identity after the formation of the complex salt, and the complex salts are stable both in the solid state as well as in the solution. That means when complex salts ionizes, they give simple ion as well as a complex ion. These are the differences. Next we have to concentrate on complex salts, or they are also known as coordination compounds. Complex compound or coordination compound or a complex salts. So now let us consider the different parts of a complex compound. So here in case of a complex compound, so if you consider this portion in potassium ferrocyanide, this is called central metal ion, and then there are 6 cyanide ions, they are called ligands, central metal ion and ligands. And central metal ion and ligands, they are shown inside a square bracket. It constitutes coordination sphere. It is called coordination sphere. And the ion outside the coordination sphere is called second sphere of attraction. So whenever a coordination compound or a complex compound undergo ionization, the species inside the coordination sphere, it forms a complex ion, and the ions outside the coordination sphere forms a simple ion. Now let us consider what is a complex compound or what is a complex salt. A compound in which a central metal atom or central metal ion is surrounded by number of atoms or ions or molecules through the coordinate bond is called a coordination compound. A compound in which a central metal atom or ion is surrounded by a definite number of atoms or ions or molecules to form through the coordinate bonds is called a coordination compound. So for example, potassium ferrocyanide, potassium ferricyanide and cryptoammonium sulfate, these 3 are examples for coordination compounds. In case of potassium ferrocyanide, the central metal ion is ferrous ion. Ion is in the ferrous state and it is surrounded by 4 cyanide ions. These cyanide ions are considered as ligands. I will explain what are ligands later on. Here, ferrous ion, central metal ion, 6 cyanide ions are the ligands. Whereas in case of potassium ferricyanide, central metal ion is ferric ion. The difference between potassium ferrocyanide and potassium ferricyanide is that iron is in a different oxidation state. In potassium ferrocyanide, iron is in the ferrous state, Fe2+ state, whereas in potassium ferricyanide, iron is in the ferric state, that is 3+ state. Here, central metal ion is ferric ion, which is surrounded by 6 cyanide ions called cyanide ligands. In case of cryptoammonium sulfate, central metal ion is cupric ion, Cu2+ ion, which is surrounded by 4 ammonium ligands. So the species inside the square bracket represent coordination sphere. Okay. Then now let us concentrate on the ligand. Next, the question is, what is the ligand? What is the ligand? Before going to understand the ligands, we should know about coordinate bond. Coordinate bond. The formation of a coordinate bond can be explained by taking the formation of a bond between X and Y. Suppose a chemical bond is to be formed between X and Y. Then the basic need is a pair of electrons is to be donated or shared between these 2 atoms, X and Y. So here in case of coordinate bond, the pair of electrons which are required for the formation of the bond is donated by one of the bonded atom. Now let us imagine X donate a pair of electron to Y. So as a result, a bond is formed between X and Y. X donate a pair of electron to Y. As a result, a chemical bond is formed, and that bond is shown by an arrow mark. The direction of the arrow mark is always from electron pair donor to electron pair acceptor. So here a coordinate bond is formed between X and Y. The direction is from X to Y. That is because here pair of electrons are donated by X atom. So in a coordinate bond, one of the bonded atom donates both the electrons which is required for the bond formation. So in case of complex compounds or coordination compound, this type of coordinate bond exists between the central metal ion and the ligands. So here, if we consider a complex compound, say for example, central metal ion, let us take the central metal ion as Mn plus and ligands as N. During the formation of a complex compound, central metal ion or atom acts as electron pair acceptor and ligand acts as electron pair donor. So ligands donate pair of electrons to the central metal ion. Ligands donate pair of electrons to the central metal atom or ion. As a result, a coordinate bond is formed between ligand and central metal atom or central metal ion. So, in complex compound, ligands acts as electron pair donors and central metal atom or ion acts as electron pair acceptors. So, on the basis of this, we can consider different types of ligands. So, after knowing this, we can define what a ligand is. A ligand is an atom or ion or molecule which can donate one or more pair of electron to the central metal atom or central metal ion to form coordinate bond in the complex compound. A ligand is an atom or an ion or a molecule which can donate one or more pair of electron to the central metal atom or ion to form coordinate bonds in complex compounds. That is a ligand. Then what are the different types of ligands? So now we come to know that the basic function of the ligand during the formation of a complex compound is to donate pair of electrons. So on the basis of the ability of a ligand to donate number of electron pairs to the central metal ion, they are classified as monodentate ligands, bidentate ligands, tridentate ligands and polydentate ligands. Monodentate, bidentate, tridentate and polydentate ligands, they are considered on the basis of the ability of a ligand to donate number of pairs of electron to the central metal atom to form number of coordinate bonds. Now let us consider a monodentate ligand. A monodentate ligand is also called unidentate ligand. Monodentate ligand or unidentate ligand. Monodentate ligand, or it is also called unidentate ligand. A monodentate ligand has only one donor atom. Hence, it can donate only one pair of electron to the central metal atom or central metal ion. So, monodentate ligand has only one donor atom. Hence, it can donate only one pair of electron to the central metal atom or central metal ion. As a result, one coordination bond is formed between ligand and central metal ion. So that type of ligands are called monodentate ligand, or it can be defined as a ligand which has only one donor atom through which it can donate one pair of electron to the central metal atom or ion to form a coordinate bond is called a monodentate ligand. So we can give many examples for monodentate ligand. In monodentate ligand, H2O or Na3, H2O, Na3, etc. are monodentate ligand. Suppose if we consider H2O, oxygen is the donor atom. Even though oxygen has two lone pairs of electron, it can donate only one lone pair of electron for the central metal atom to form a coordination bond. Or in case of ammonia, nitrogen atom has a lone pair of electron, it can donate one pair of electron to the central metal atom to form a coordination bond. So these two are examples for monodentate ligands. So after this monodentate ligand, now then consider bidentate ligands. Bidentate ligands. Bidentate ligands, as the name itself suggests that it can donate two pairs of electrons to the central metal atom. So a ligand which has two donor atoms through which it can donate two lone pairs of electrons to the central metal atom or ion to form two coordinate bonds is called a bidentate ligand. A ligand which can donate two a ligand which has two donor atoms through which it can donate two lone pairs of electron to the central metal atom to form two coordinate bonds is called a bidentate ligand. For bidentate ligand, we can give the example of oxalate ion. Oxalate ion. Oxalate ion is COO minus. COO minus. So here the two terminal oxygen of the oxalate ions are the donor atom. This oxygen donates one pair of electron and this oxygen another pair of electron. So suppose if there is a central metal ion, then one coordinate bond, another coordinate bond. It can form two coordinate bonds with the central metal ion. So that's why it's an example for a bidentate ligand. Or one more example is ethylene diamine. Ethylene diamine is also an example for bidentate ligand. So if you consider ethylene diamine, it is like this: CH2, NH2. This is ethylene diamine. The NH2 group, the nitrogen atom donate one pair of electron. This nitrogen also donate another pair of electron. Two coordinate bonds are formed between the ligand and the central metal atom. So that's why these two are examples for bidentate ligand. Next we go to tridentate ligand. As the name itself suggests that it can form three coordinate bonds. It can form three coordinate bonds into the central metal ion. A ligand which has three donor atoms through which each can donate three pairs of electron to the central metal atom to form three coordinate bonds is called a tridentate ligand. Example for tridentate ligand is diethylene triamine. Tridentate ligand. So here example is diethylene triamine. Diethylene triamine. In the diethylene triamine, it's like this: CH2, NH2, NH, CH2, NH2. This is diethylene triamine. Now here the donor atoms are, so one nitrogen, second nitrogen and third nitrogen. So these three nitrogen atoms of the NH2 group, they can donate one pair of electron. A total of three pairs of electrons are donated to the central metal atom to form three coordinate bonds. That's why it is a tridentate ligand. So now we know what is a monotheistic ligand. It has only one donor atom through which it can donate one pair of electron to the central metal atom or ion to form one coordinate bond in a complex compound. Or in a bidentate ligand, which is also called a bidentate ligand which has two donor atoms through which it can donate two pairs of electron to the central metal atom to form two coordinate bonds, called a bidentate ligand. A tridentate ligand has three donor atoms through which it can donate three pairs of electron to the central metal ion to form three coordinate bonds. Example for monodentate ligand: water and ammonia. Bidentate ligand: oxalate ion and ethylene diamine. Bidentate ligand: ethylene diamine. And tridentate ligand: diethylene triamine. Next we have to go for polydentate ligand. Polydentate ligand. In polydentate ligand, which have more than three donor atoms, polydentate ligands have more than three donor atoms, hence they can donate more than three electron pairs to the central metal atom to form more than three coordinate bonds. If polydentate ligand has more than three donor atoms, they can donate more than three pairs of electron to the central metal atom to form more than three coordinate bonds in a complex compound. Best example for a polydentate ligand is EDTA. EDTA means ethylene diamine tetraacetate ion. Ethylene diamine tetraacetate ion. First I will write its structure, then you you can identify the donor atoms N, CH2, CH2, N. CH2CO minus. So this is ethylene diamine tetraacetate ion. So let us consider the donor atoms. So terminal oxygen of this acetate group, another terminal acetate here. There are 4 terminal oxygens of the acetate atoms, 4 donor atoms, and 2 nitrogen atoms of the amine group. Totally, EDTA has 6 donor atoms. 1, 2, 3, 4, 5, 6. That's why it can donate 6 pairs of electrons to the central metal atom to form 6 coordination bonds. That's why it is considered as a qualitative ligand. So with this, I will stop and I will continue in the next class.